Question 14 is one of these funny pulley on the edge of the table questions. So we've got a block of wood, which is wood A, and it is 0.5 kilograms resting on a rough horizontal table. Remember, because it's rough, friction will have to be involved. And it's attached to the end of this light inextensible string, which passes over a pulley over the edge of the table and then attaches to mass B, which is a ball of 0.8 kilograms. And it's shown in the figure. The resistance to the motion of A from the rough table has a constant magnitude of F. So let's put that on. We've got friction. It's acting opposite to the motion with size F. What else are we told? The system is released from rest, and after the release, B descends a distance of 0.4 meters in 5 seconds, and then we're going to be calculating different things. Now, first off, I'm going to mark on all the forces that are going on. So I know that I've got a weight down here of 0.5 G, and there'll be some sort of reaction from the table opposite that. Then I've got a tension in the string, and I'm going to call the tension T, of course, acting the same throughout all the string because it is light inextensible string and the pulley is smooth. And we've got the weight going down here of 0.8 G. And B descends a distance, which means that the acceleration is downwards here because B is going down. And there, obviously, if B is going down, A is going to be going to the right. So let's put on that acceleration here as well. And the acceleration will be the same. Again, it's a light inextensible string over a smooth pulley. So first we want to find out what the acceleration of A is, of B is, which is going to be the same as the acceleration of A. And we're going to use suvat for this because we've been given quite a lot of information about the motion of B in the question. So I know that S is equal to 0.4 meters. It tells me it descends a distance of 0.4. U is 0 because the system was released from rest. V, I don't know. A is what I'm trying to find out. And T is 0.5 seconds. That's what it said in the question. 0.5 seconds is the time it takes to descend 0.4 meters. So if I want to find out what A is, I'm going to be using S equals UT plus a half AT squared. Remember, that is just 0, so that can disappear. And so I can rearrange nice and easily. A is going to be 2S divided by T squared. So that's 2 times 0.4 divided by, divided by 0.5 squared. And subbing all of those in, I should get that the acceleration is 3.2 meters per second squared. There we go. So for part B then, we want to find out what the tension is in the string. So to find the tension, I'm going to do that thing where we just focus on particle B. So I'm cutting off here and focusing only on B. And I know that if I resolve downwards, because the acceleration is downwards, then the resultant force down is equal to the mass times the acceleration. We've just worked out what the acceleration is. I want to work out what the tension is. So to work out the resultant force downwards, I've got 0.8 G downwards. I need to take away the tension because that's upwards. And that's going to be equal to 0.8 times the acceleration, which is 3.2. And I just need to rearrange this to find out what T is. So I will get that T is equal to 0.8 G, so 0.8 times 9.8, take away 0.8 times 3.2. And that gives me a tension of 5.3 newtons. Okay then, so for part C. For C, we are finding the value of F, so this answer here. So let's cut off at A instead this time. And we're going to do the same sort of thing that we did for part B, but this time we're looking at A. We know that the result, if I resolve to the right, because here the acceleration is to the right, then the resultant force is equal to the mass times the acceleration. Well, to the right I've got the tension, which is 5.3, the same as the tension that we found for part B. Take away F is equal to the mass, which is 0.5, times the acceleration, which is 3.2. So I can rearrange to find what F is. So F is 5.3 minus 0.5 times 3.2. And then if we type this in to our calculator, 5.3 minus 0.5 times 3.2, we get an answer of 3.7. So the frictional force is 3.7 newtons. Let me just fit on there. And then finally for part D, this is again asking about assumptions. We've had loads of questions about assumptions now. It says, state how in your calculations you have used the information that the string is inextensible. And what we're basically saying is that if the string is inextensible, basically we're saying the string isn't stretching, it's always staying the same length, then the acceleration of A is going to be the same as the acceleration of B. It can't be moving, stretching at different places at different amounts, it's always staying the same length. So if one thing is moving by a certain acceleration, the other end of the string will also be accelerating by the same amount. So we'll say acceleration of B is equal to the acceleration of A. And that's how we've used that inextensible idea.